So these images here, where we've got myself in the foreground in the blue, and we've got the wall in the background in the red, and we've got these green pixels in the middle that are incorrect information on the edges, and this is where the camera's got it wrong. We have an algorithm to correct that, and we call it our mixed pixel algorithm. And it's one of these things that just happened to be developed kind of by accident. It was developed by a PhD student, and his original project was to actually refocus images. And this was an interesting project using a range camera, because with a normal camera, if you've got part of an image that's in focus and another part that's out of focus, it can be quite difficult to correct that out of focus part, because the amount of defocus changes with distance from the camera. But of course, with the range camera, we've got a distance measurement. So if we know how far away the object is, it's easier to correct the defocus and refocus the image. So this was the aim of his PhD project. But what we realized earlier on is that when you've got objects that are out of focus, they're blurred. So you could have two objects. If they're blurred, they're going to blur together. And one pixel in the image is getting distance information from both objects. And that's actually what's happening here on the edges. The distance information from both objects is actually interfering with each other and creating an incorrect distance value. So what we realized for this refocusing project is that we first had to solve this mixing problem and correct for these mixed distances and separate those values out. So it actually turned out that that problem was a little bit harder than we anticipated. We were able to do it, but this particular student's project actually became more about doing this mixed pixel separation than it was about refocusing the images, which was the original idea. So this camera in the corner is one that we've built ourselves, and we use it to test and evaluate and develop our algorithms on. And here we can see it sitting in front of the translation stage, so we use that to check our measurement distance against the translation stage. The illumination here, we've got quite a large number of laser diodes around the outside of the lens here, and they're quite powerful, and it means that we have to use our protective eyewear when we're using it to make sure we don't damage our eyesight.